Alright, for number 2b, again we're stating the interval of convergence for the following series. Let me write it up here real quick. So we have the sum from n equals 1 to infinity of n to the n over x to the n. So like all these other ones where we're finding the intervals of convergence, we're going to use the ratio test. So in using the ratio test, we're going to get absolute value. Remember, you do a sub n plus 1 divided by a sub n. In other words, a sub n plus 1 times the reciprocal. So we're going to get n plus 1 to the n plus 1 divided by x to the n plus 1 times, so we're going to get the reciprocal of this, x to the n over n to the n. So now we're going to try to see what cancels out. So for the x's, it's pretty simple. We get an x left in the denominator. So for this one up here, it's not going to be quite as simple. So let's rewrite what we have so far. I'm going to write the 1 over x by itself and just put the absolute value bars around that, because the n's are always positive numbers anyway. We don't need the absolute value bars for that. So the part of this product that includes the n's is n plus 1 to the n plus 1 over n to the n. And remember that we're doing the limit of n goes to infinity of this, and in order for this to converge by a ratio test, we want this all to be less than 1. So what we can see here is that n plus 1 to the n plus 1 can be split up into n plus 1 to the n times an n plus 1, because we have a power of n plus 1. So we have n copies of this and an additional copy. We want to do that because it's always best if you can get the powers to match, because then you'll get stuff to cancel out more easily. Divided by n to the n. So I'm leaving this and I'm just working with the n part now. So n plus 1 to the n over n to the n is n plus 1 over n to the n. And we have an additional times n plus 1. So this part is actually, should look familiar to you. If we divide each term by n, we get 1 plus 1 over n to the n plus 1. So 1 plus 1 over n to the n, as n goes to infinity, that's the limit definition of the number e. So we have e times n plus 1 is what this whole part simplified to. This was divided by absolute value of x, multiplied by 1 over, but divided by absolute value of x. And we want this to be less than 1, as the limit of that n goes to infinity. Well, you can see here, since x has to be some finite number, no matter what number you choose here, this limit is going to go to infinity, because the n is always going to infinity. So any x you choose, this is going to be false, because there's no way this can be less than 1. So remember, in this case, for these problems, x is essentially a constant that you're trying to find out the restrictions on. And in this case, there is no x that you could pick such that this limit would even be finite, much less than 1. So in this case, we have, and it wouldn't even work if x is 0, because then we'd have 0 in the denominator. So there's no such x. So therefore, the interval of convergence would be, the IOC would be, you could write that for empty set, or in other words, does not exist. There's no x that could make this converge. So our interval of convergence doesn't have anything in it. So we have empty set, or does not exist for the interval of convergence for this series.